All right, so the Unit 3 review is the test is tomorrow. The first one, name the plane below. You've seen this question. This will now be the third time to see this question on a test. The reason it keeps coming back is because people keep missing it. It's a multiple choice question. You need to know how to name a plane. So hopefully this time, everyone's going to get it right. So how do you name a plane? You can name it by 3 non-collinear points that are on the plane, or you can name it by the capital script letter that is on the plane also. So if we have plane, this M right here doesn't have a point next to it, and that's a script letter. So that is plane M. That's one way to name this. The other is, I could say D, E, and A. You will always use capital letters with planes, never the lowercase letters. See how there's like the J right here? That is talking about a line. This K, that's a line. Lowercase are for lines, capitals are for planes. And I can't say D, E, and F because those are collinear. Those make a line, so I can't name it that way. Point B up here is not even on the plane. It's floating above the plane. Point C is floating below the plane. Those are not even on the plane, so we're not using those. So another way is, again, I'm going back to 3 non-collinear points. So plane EAF. And there's a lot of different combinations to name it using 3 non-collinear points. As long as I'm not using DEF, FED, EFD, not those 3. I have to use that point A and then 2 of the other points. Or call it plane M. Okay, so number 2, I'm going to modify a little bit. I'm going to take out and the length of the segment because I happen to know that is not on the test. You will be asked to find the midpoint given the end points. So there's 2 different ways you could do this. You could use the midpoint formula, which is the average of the x's and the average of the y's. So you do x1 plus x2 and divide it by 2, comma, y1 plus y2 and divide it by 2. So it doesn't matter which one you call point 1 and which one you call point 2. So if this is point 1, then that's x1, y1. And then this would be x2, y2. Because the 1 and the 2 are just naming the point, either point 1 or point 2. Alright, so if I'm going to do this in formula, I want to take my x values. x1 is -1. And x2 is +3. And then the y's, y1 I have as 4, y2 I have as 8, -1 plus 3, that's 2, so 2 over 2. 4 plus 8, that's 12, so I have 12 over 2. So the coordinate, 2 divided by 2 is 1, and 12 divided by 2 is 6. So the coordinate of the midpoint, an xy coordinate, is the point 1, 6. The other way is you can graph it, graph the line and find the middle of the line. That's fine. Or you can use the midpoint. Or you could do it that way that I showed you where you do -1, 4. Oops, sorry, you split them up. That's not how I did it. Yeah, you do -1, and 4. And then you're going to the point 3 and 8. From -1 to 3 is how many spaces? That's going to be, I didn't mean to erase that part. From -1 to 3 is 4 spaces. But, oh, that's what it is. I missed the A, B, and the C. So if this is A to B and M is in the middle. But if I only want to go halfway, then I'm going to go half of the 4 spaces to get to the middle, which is 2 spaces. So I'm only going to go 2 spaces. So -1 plus 2 gets me to 1. And that's them. And then do the same thing for the Y's. From 4 to 8 is 4 spaces. But if I only want to go half that distance, then I'm only going to go 2 spaces, because that's half of 4. And then if I started up forward, I move 2 spaces, that gets me to 6. So the Y value is 6. So my midpoint is at 1, 6. So they both get me to the midpoint of the line. Okay, so then on number 3, determine the line perpendicular to the line x minus 3y equals 9, and it passes through the point 3, -1. So you do have to remember perpendicular. The relationship for a perpendicular line is opposite reciprocal slopes. All right, so if you have a line, x minus 3y equals 9, and you want a new line that is perpendicular to that, then you need the opposite reciprocal slope. So you need to know what the slope of the line is, of the original line. So to do that, I'm going to take this x minus 3y equals 9. I'm going to rearrange this to slope-intercept form, y equals mx plus b. Remember that? Y equals mx plus b, because I know that m is the slope. Just a minute. Okay, so m is the slope and b is the y-intercept. Intercept is where the graph touches the y-axis. So if I rearrange this into slope-intercept form, I know that the slope is whatever is directly in front of x. So that's what I'm looking for. I want to find out what m is. All right, so I want to solve for y. I want y by itself. So I am going to subtract x. -3y equals -x plus 9. But I need to solve all the way for y. So I need to do another step. I need to divide by -3. And I'm dividing everything by -3. I'm dividing the x by -3, and I'm dividing the 9 by -3. So y equals negative over a negative is a positive, and I'm going to go ahead and write this as 1/3 x, or x over 3, it's the same, plus 9 divided by -3. Oh, so positive and a negative, so it's going to be negative. 9 over 3 is 3. So remember, I rearranged this into slope-intercept form to figure out what the slope is. The slope is 1/3. This is for the original line, but I want a slope perpendicular to that. So I want the opposite reciprocal. So I'm taking this 1/3, and I want the opposite reciprocal slope. So 1 over 3 is going to become 3 over 1. That's the reciprocal, and the opposite sign. So I'm going to make it's positive, so I'm going to make it negative. And so this is a slope of -3. So my new slope is -3. So the slope of my new line is -3. Okay, and then this is where you can go two different ways. One way is you can use the point slope form. And a point, because you have a point, xy, 3, -1. Right here, this is an xy. x1, y1. It's a given point. And you could plug it into point slope, where we have y minus y1 equals m times x minus x1. And actually I want to make m is red. So if I do this, I want to plug in for the y1, the m, and the x1. And here's my x1, y1 from the point. So y minus my y1, which is -1, so I'm going to put it in parentheses because it's a negative and I don't want to mess that up, being extra careful, equals my new slope, which is -3, already found that, times x minus x1, and x1 is 3. So there's the equation. And I want, it doesn't say it in this problem, but I want my final answer to be in slope-intercept form. So that means I need to solve this back into slope-intercept form. So this would be y plus 1 equals -3 times x minus 3. And then solve it back into slope-intercept. Another way to do that, after you find your new slope, which I feel is a much easier way, but that's the official way I'm supposed to teach you, is the way I just did it. So if you know you want y equals mx plus b, right? Whoa, what did I just do? You want y equals mx plus b for your new line. And you already know that your m is -3. So you have y equals -3 x plus b. So all I'm missing is the y-intercept. This is all I need. I could do all the other steps on the other side, but what if I just graphed it? What if you just did, and I have graph paper on the cart, you're welcome to at any time. But if I did a quick graph, this point 3, -1, 1, 2, 3, -1. I want this point to be on my new line, and I know my new line has a slope of -3. So if it's a slope of negative, it's going to go down to the right. It's going to be slanted down to the right. So I can go up 3 and over 1. Up 3 over 1. Because I just want to see where it touches the x-axis, or the y-axis, I'm sorry. 1, 2, 3, and over 1. This has to be taller. 1, 2, 3, and over 1. And there it is, right there. And then I just count my lines. And that's 8 lines. It's a horrible line. But now I know that this is 8. So y equals -3x plus 8. Isn't that so much easier? How do I do that? I know there's a way. Oh well. Never mind. I know there's a way to make that into a graph, but I don't know how to do it right now. Oh well, you just get my, oh, that's how. This, then that. It can't read it. Okay. I'm just trying to be fancy. Oh well, that's my answer. Y equals negative 3x plus 8. So over here on the left where I did it with the algebra problem, after I rearranged this into slope-intercept form, it also gives me 8. And then it also gives me the same one, negative 3x plus 8. So once you get your slope, you can just graph it and see where the graph touches the y-axis. And there's your line. Okay, number 4, I took that problem off your test. So you don't need to worry about that one. Number 5, determine the slope of the line that passes through the points. Okay, slope formula. I'm going to write this lots of ways. So slope is m, and it's rise over run.
Do you need a graph to see the slope? Do you need graph always?
You can use like graph it and count the blocks, or you can do it. I'm going to show you how to do it with a formula also. It's really not that bad. Rise over run, so it's also, I'm going to draw that's up and down, over side to side, just to make sure, get all this different ways that this can be said. This is all saying the same thing. All the different ways that you could say slope. Change in y over change in x. The little triangle symbol means delta. Delta y over delta x. It means the change in y over the change in x. Or the formula is y2 minus y1 over x2 minus x1. And again, it doesn't matter which point you call point 1 and which point you call point 2, as long as you're consistent in naming it.
Does x always go first?
X is always on the bottom for slope, and y is always on the top.
Okay.
Alright, so I'm going to call this point 2 and this point 1. So my y's. So I'm looking for y's. So I'm going to do negative 1 minus 14, and that's on top. And then on the bottom, I'm going to do x's. So I have 2 minus negative 3. And that gives me the slope. So negative 1 minus 14 is negative 15. And 2 plus 3 gives me 5. So my slope is negative 3. Determine the slope of the line that passes through the points. The slope of the line is a slope of negative 3. And then it says, what is the slope of the line that is parallel? Well, we know that parallel means same slope. So, m equals negative 3. What is the slope of the line that is perpendicular? Perpendicular is opposite reciprocal. So, m equals positive 1 over 3. Because it's the opposite sign and flip the fraction. Reciprocal means flip the fraction. Okay, so that's the front page. On number 6, I feel like that's a typo where it says intersecting. I feel like that should say neither or no relationship, because perpendicular lines are intersecting. Alright, so this says, are the lines parallel perpendicular, or neither. So if they're parallel, again, that means same slope. If they're perpendicular, that means opposite reciprocal. Opposite reciprocal. And then neither is just anything else. Oh, yeah. All right, so to do that, to compare slopes, we need to rearrange these into slope-intercept form. So we could look to see if we have y equals mx plus b, we are trying to compare slopes, so we want to know what the m value is. That's all we're worried about. Easiest way to do that is rearrange the slope-intercept. Okay, so that's what I'm going to do. Here I have x plus 2y equals 2. I want y by itself, so I'm subtracting x. So 2y equals negative x plus 2. And then I want y by itself, so I'm dividing by 2. Divide everything by 2. Y equals negative 1/2 x plus 1. And then I need to do the same thing for this one. I'm not going to have a lot of space here. All right, so I have 6x minus 3y equals 21. So I'm going to subtract the 6x. Negative 3y equals negative 6x plus 21. Then divide by negative 3. Divide everything by negative 3. So y equals negative 6 divided by negative 3 is positive 2. X. 21 divided by negative 3 is negative 7. All right, and remember, I'm only comparing their slopes. That's all I'm worried about. I have negative 1/2, and I have positive 2. Those are opposite reciprocals, right? So these are perpendicular lines. So for A, they're perpendicular. I don't have space to do B, so I'm going to skip it. And let's look at C. And do the same thing. I'm just going to, oh, look, y equals negative 4x minus 2. I don't have to do the top equation. Very nice. So the slope is negative 4. Now I just need to rearrange the bottom equation. I want y by itself, so I'm going to subtract 12x. So I have 3y equals negative 12x plus 27. And then divide everything by 3 so that y is by itself. Y equals negative 4x plus 9. All right, so my slope there is negative 4. So my slope here in the top equation is negative 4, and my slope in the bottom equation is negative 4. They have the same slope. Same slope means the lines are parallel. And then the last one is a special case. I feel it's a little bit tricky. I'm not going to go all the way into it. We'll just kind of talk about it. If you have an equation x equals a number, that means you have a vertical line. If you have a line that's y equals a number, that means you have a horizontal line. So if you have a vertical line and a horizontal line, are they parallel, perpendicular, or neither? Perpendicular. Yes, it's like the x-axis and the y-axis. They're perpendicular. They meet at 90 degrees. The reason that case is special is because when you solve for the slope of a vertical line, it's something called an undefined slope, and I don't really feel that we need to be getting into undefined slopes. A horizontal line's not so bad. It just has a slope of 0.
Undefined slope is a slope that you can't really solve, right?
Right, because the slope of a horizontal line, m equals 0. So if m equals 0, and you want the opposite reciprocal of 0, you move it to the denominator, right? So then you would have like a number over 0, but that's dividing by 0, and that breaks all of the laws of mathematics, and you cannot divide by 0. And so that's why it's called undefined. Your calculator will tell you error. If you just do like 5 divided by 0, you can't. And I feel like that's plenty of depth to go into for that. So really, A and C are good examples, and we'll leave it there. All right, so number 7, write the point-slope form of the equation of the point. Yeah, I took that off. Don't worry about that. No.
It's like one of your corresponding ones, like these
Corresponding are in the same position. Okay, so let's look at number 8. Identify the relationship between each pair of angles. So again, it's a lot easier for me to point it out on my screen because I can just click and erase. But let's just look. Angle 1 and angle 10. Well, here's angle 1, and here's angle 10. So what is the relationship between 1 and 10? Vertical angles. Very good, because this one has a V, this one's a V. They share a vertex. You have a lot of V's going on. Vertical angles also starts with a V. Yes, it is vertical angles. And the relationship is that they are congruent. Vertical angles are congruent. It didn't ask for that, but a little extra doesn't help. Doesn't hurt. Angle 7 and angle 5. So here's angle 7, and here's angle 5. It is alternate interior because these two parallel lines, they're inside, both angles are inside the parallel lines, and then they're on opposite sides of the transversal, or opposite sides of the street if the transversal is the street. So these are alternate interior. Alternate interior is congruent. Up next is angle 3 and angle 9. Here is angle 3, and here is angle 9.
Supplementary.
Well, from the list,
Same side.
they are supplementary, but supplementary is not on this list. They're not same side interior because they're not touching two different parallel lines. It has to be a linear pair. Angle 3 and angle 9 make up this. The two angle measures are going to add to 180 to make this straight line. Linear pair, a line pair. That one's a little bit tricky. Angle 3 plus angle 9 equal 180. So they are supplementary. But the reason that they're supplementary is because they're a linear pair.
So that's the reason why they are, right?
Mm-hmm. Angle 11 and angle 12. All right, so here's 12, bless you, and here's 11. Those are corresponding because on the two parallel lines, if you look at the intersection, 12 is in the bottom right corner of the intersection, 11 is in the bottom right corner of the intersection. So you might want to say same side because they are on the same side of the transversal, but 11 is interior and 12 is exterior. So then you check corresponding. And corresponding angles are congruent. Okay, so 4 and 8. Here's 8. Here's 4.
Alternate exterior.
Alternate exterior. They're on the outside of the parallel lines, and their alternating sides of the transversal and alternate exterior are congruent. Angle 2 and angle 4. All right, so here are the two parallel lines. They are on opposite sides of the transversal, but angle 2 is interior and angle 4 is exterior, so these are no relationship. So 2 and 4, no relationship. Last one is 6 and 11. Here's 11, and here is 6. 6 and 11 have to be same side, and they are both interior. Same side are supplementary, so angle 11 plus angle 6 equal 180. So whenever you look and you see this, if you were to outline them and they make this little rectangle, if you compare that with a square, now they're not square. They could be any combination of angles that add up to 180. But if you had a square, you would have 90 degrees in that corner and you would have 90 degrees in that corner. And if you added these together, that would be 180 degrees. So if you see that rectangle shape whenever you outline your angles that you're talking about, like right here, they're going to add to 180. It doesn't mean they're both 90. It just means together they're 180. It's just a kind of a shape that sticks out. Okay, number 9. I'm not going to solve number 9 all the way because you don't have one just like that on the test. But these are vertical angles. And vertical angles are congruent. And that's just where I'm going to leave that one. So you would take the two and say they're equal to each other. On this one, again, I'm not going to work through it, but I will talk about it briefly. This is a linear pair. It's a pair of angles that make a line, and so they are supplementary. So I would say 11x minus 15 plus 5x minus 13 equals 180. And then solve for x that way. Okay, so I'll go ahead and write the other one out. 6x plus 7 equals 8x minus 17. And then on number 11, same thing. I'm not going to go through that one. This relationship is alternate interior. And alternate interior are congruent. So if I wanted to solve this one, I would say 10x minus 23 equals 137. Again, for number 12, I'm not going to worry about actually solving number 12, but I do want to look at the relationship. These are corresponding angles. And corresponding angles are congruent. So if I wanted to solve this, I would say 74 equals 9x plus 11. Number 13, I do want to solve. 13, again, let's look at the angle relationship. There's an angle, there's the other angle. So it kind of looks like part of a rectangle. So that's my clue that these are going to add up to be 180. These are same side interior. Same side interior. And same side are supplementary. Same side supplementary. So that means I want to say that 96 plus 6x minus 30 equals 180. You got to be careful with same side interior and same side exterior because they're supplementary, not congruent. All right, so the first thing I'm going to do to solve this is combine my like terms. Before I start solving, I need to simplify. This is CLT. Combined like terms. 96 minus 30 is 66. So I have 66 plus 6x equals 180. And then I can begin the solving, where I subtract the 66. So 6x equals 114. And then the last step is to divide by 6. So x equals 19. Okay, I have another one, and this one actually is also called number 13. And I do want to go over this one also. All right, so the angle right there, and then the angle down here. Those are alternating sides of the transversal, and they're on the exterior of the parallel lines. So these are alternate exterior, and alternate exterior are congruent. So to set this up, I can say that 33 equals 7x plus 5. And then solve. To solve it, I'm going to subtract the 5. So 28 equals 7x. And then divide by 7. So 4 equals x. And that's what this asked for, is the value of x. And it's 4. All right, so what conclusion can you make if J is parallel to K? So this is assuming that these lines are parallel. If these lines are parallel, angle 1 and angle 8, those are same side exterior. Same side is supplementary. Is that what A says? No, that says congruent. They're not congruent. They're supplementary, so that's not true. What about 3 and 5? Here's 3. Here's 5. Those are alternate interior. Alternate interior are congruent, not supplementary. They don't add to 180. So it's not those. What about 3 and 6?
Those are the same. Yeah, same size.
Yeah, so these add to 180, and that is what this one says. And then to look at D real quick, 1 and 3. So angle 1 and angle 3, those are congruent. Those are vertical angles, and vertical angles are congruent. But the question says, what conclusion can you make if J and K are parallel? So these being vertical angles has absolutely nothing to do with J being parallel to K. That's why that would not be the correct choice. C is the best choice. Okay, so on the back, don't want to run out of time. 15, not going to worry about that. 17, not worrying about number 17. On number 16, if you're given that ray BD bisects angle ABC, and your conclusion is that ABD is congruent to angle DBC, what is the justification? Well, it kind of helps just to sketch a quick picture. All right. So BD, so this is B and this is D, bisects A, B, and C. Bisect means to cut in half, so it means that these are the same. And that gives me a lot of information right there. So if this is saying that these two angles are congruent, it's because they've been bisected, so this would be A. Definition of an angle bisector. So nothing else even makes sense. A straight angle, that's a straight line. There's no straight line in this picture. Vertical angles, there's no vertical angles in this picture. Angle addition postulate, there's angles, you could add them together, but that isn't what this conclusion says. All right, so that's A. We're skipping the algebraic proof, not worried about that. And then on this one, if I were to do a proof real quick, I'm given two elements, so I'm going to make both of those given statements. So it says that A is parallel to B, and I know that because it's given to me. It says C is parallel to D. I know that because it's given to me. And I'm going to mark it in my picture. This is parallel to B, and this is parallel here. Prove that 13 is congruent to 4. So I want to prove that 13 is congruent to 4, and that's the last statement. Angle 13 is congruent to angle 4. All right, so if these are parallel, and I'm trying to get to 4, I could start with, and there's more than one way to get to this, but I could start with 13 is congruent to angle 5, because 13 is here, and 5 is here, and I'm kind of working my way towards 4. So I could say that angle 13 is congruent to angle 5, because they are corresponding angles, which is the corresponding angles postulate, CAP. All right, so now I'm up here at 5. 5 and 4, there is a relationship there, right? Those are alternate exterior. So I could say that angle 5 is congruent to angle 4 because they're alternate exterior angles. The alternate exterior angles theorem. So then, if 5 is congruent to 4 and 13 is congruent to 5, I can say that 13 is congruent to 4 by the transitive property. Or you could also say substitution. Those two are really close. Either one would be acceptable. You'll only have to fill in one of these missing lines. You won't have to write the entire proof by yourself. Just take a little weight off there. There will be like one of these will be a blank, one of the reasons, and you'll have to justify the step. And when you want to justify a step, like if this corresponding wasn't there, you have to look to, oh, well that's a bad example. If alternate exterior was not there, you have to look to the statement above. So if this is the blank, then I have to go to the statement above. How did I get from angle 13 is congruent to angle 5, 5 is to 14? How did you get from this one to this one? Well, this isn't really best example for what I was just trying to explain. Always look to the line above. And that's it. That's what I got for the review.